This is AP problem number 13. For A, it says, in the boxes provided, draw the complete Lewis structure, the electron dot diagram, for each of the three molecules represented below. The three molecules represented below are CF4, PF5, and SF4. So for A, the total electrons needed was 32, and so I drew carbon with 4 single bonds with fluorine attached at the end with their 3 lone pairs, and when I counted it up, it added up to 32. And how you do this is to make sure you have the correct amount of electrons. Is carbon has 4 valence electrons, fluorine has 7 valence electrons, so you do 7 times 4 because there's a 4 represented by F4, and you get 28 plus the 4 carbon valence electrons is 32. For PF5, it needed 40 electrons, so I drew P as a central atom with 5 single bonds with fluorine at the end with all of its lone pairs again, and I did the same sort of math and I got 40. And then for SF4, it needed 34, so I had the 4 single bonds with F at the end and S as a central atom, and since S can break the octet rule, it can have its lone pair right there to get this correct amount of valence electrons. For B, it says, on the basis of the Lewis structures drawn above, answer the following questions about the particular molecule indicated. What is the FCF bond angle in CF4? The angle in FCF4 represented right here and is a 109.5 degrees, and that is because it's tetrahedral because it has 4 single bonds and 0 lone pairs. And for part 2 of B, it says, what is a hybridization of the valence orbitals of P and PF5? And the hybridization, I got DSP3, and how I determined this was because since there's 1, 2, 3, 4, 5, it's DSP3 because D counts as 1, plus S counts as 1, and then plus the other 3, that adds up to 5 for its hybridization. And for part 3 of B, it says, what is a geometric shape formed by the atoms in SF4? And the geometric shape I said was seesaw, and that is because it has 4 single bonds and 1 lone pair, so that gets it to be seesaw. And for part C, it says 2 Lewis structures can be drawn from the OPF3 molecule as shown below. How many sigma bonds and how many pi bonds are in structure 1? So looking at structure 1, and I determined that there are 4 sigma bonds and 1 pi bond. A sigma bond represents single bonds and pi bonds represent double or triple bonds. So since there is only 1 double bond, there's only 1 pi bond, and since there are 4 sigma bonds, or 3 sigma bonds represented, and then which one of the 2 structures best represent a molecule of OPF3? Justify your answer in terms of the formal charge. And I determined that structure 1 was the best representation of a molecule for OPF3 because the formal charge for all of its atoms have 0, which is the ideal case when looking at structures. And that is it. There's a correction I want to make on my part for part C number 2, or number 1, and I had stated that there was 3 sigma bonds, but I then determined that it's 4 sigma bonds because a double bond is made out of 1 sigma bond and 1 pi bond. So this double bond also has a sigma bond incorporated, so therefore there are 4 sigma bonds and not 3.